Okay, so you roll two fair dice, six-sided dice, of which one is red and the other is green. What is the probability that the number on the red die is strictly less than the number on the green die? Okay, so let's say if we were creating the sample space for these, that means that all potential outcomes, right? How many numbers are on the dice? Six. Okay, so we're gonna say 1, 2, 3, 4, 5, 6, and this guy's gonna be the red, and then this guy's gonna be the green, and we're gonna say 1, 2, 3, 4, 5, 6. Everybody get so far? Okay, now you're gonna compare. If I roll a one over here and one over here, do I win or lose? Lose. So that's gonna be no. Okay. What about 2 and 1? If I get a 2 on the red and a 1 on the green, lose. Okay, so we're gonna repeat this pattern. Okay, and then you're gonna ask yourself, if I get a 2 on the green, 1 on the red, that's a win. So these are all wins. Okay, in the next column, lose and then win. And then lose, lose, win, win, win. Then lose, 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 win, win, lose, 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 win, and lose, 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 lose. Everybody okay? Okay, so we just drew the sample space for that guy. Okay, now, how many wins do we have? Out of how many? Can we simplify that?
No, ma'am. Yes, ma'am. Five, 12.
Okay. You said that so confidently.
I was testing you.
Oh yeah? No. Questions on that one?
Ma'am.
Are we okay? Okay, so when you get kind of like this kind of situation, best way to do it is to draw it out. Okay, so that way you can see visually what's going on. Okay, on your quiz, you have to be able to interpret, talking about, are you guaranteed to have something happen? How to use a random number table. So that's the digits. And let's say that they're wanting 30 people, 1 to 30, right? So you're going to do every 2 digits. So 0, 1, you're going to label your kids 0, 1 all the way to 30. And then you're going to read from left to right the random number table. And you're going to take any number that is in between 1 to 30. If it doesn't work, you're going to skip it and go to the next 2 digits. Do you mean to pull it up? Okay. All right. So give me 2 seconds. I see you. So if you had 30 kids that you were looking at, right? You would label them from 1 to 30 using 2 digits. Okay, so you have to label them and you have to specify 0, 1 all the way to 30. So we would read from left to right. Let's say that we're taking 5 people, right? Is 11 in between 1 to 30? Yes. Is 16 between 1 to 30? Yes. I'm going to blow this up so you can actually see it. Okay, so 11 is 1, 16 is 1. Is 43? No. Is 63? No. Is 18? Yes. Is 75? Nope. Is 6? Yes. Is 13? All right, then we're done. Oh, I'm sorry. Yeah, no, that's fine. Ta-da. Yep. So you would describe that process. And you want to make sure you say left to right. Yeah. Okay. All right, what was the question? What the difference between mutually exclusive and independent are. Okay, so what is independent? Let's start there. Look back at your notes if you don't remember. What is independent? Okay. So you said, nope. You said independent is where the outcome of each event does not impact the other. right? Okay. What does mutually exclusive mean? Look in your definition. So two events can't happen at the same time. Mutually exclusive, two events cannot happen at the same time. Is there anything else on these on your notes? Say it again. They cannot be independent. Do you know what number it was? Can you pull it up? Okay. When they say or, you're going to use that formula of probability of A plus the probability of B minus the intersection of those two. You're going to use the numbers from the two-way table. Yes? Okay. When they're and, that's where they cross over in the two-way table. Okay, so here it is. Here's your two-way table. Let's say that you want to know, let's say that you want to know the probability of A and the probability of B. Okay, so let's say that you want to know the probability of yes and yes, right? Then you would just take this guy, whatever number that is, right? If we wanted to know the probability of Y or the probability of B of Y, sorry, I set this up wrong. Then we would take this amount plus this amount minus their crossover. So if we wanted to know the probability of AY or BY, then we would take this amount plus this amount minus their crossover. Yes? When do you divide? So when if ever it says given something, then that's when you're dividing it by that. Yeah? Good? Show you an example of that? Okay, go back to your notes. You're wanting the given stuff, the conditional probability? Mo, conditional probability? So given such and such?
Stupid said no, lovely one. No, second.
Let's do. Yeah, go to Taco Tongue day 2. This guy. All right. Bruno doesn't have it. Here, I'll give it to you. Okay, so you had this information, right? Okay. We're taking a look at, given that the person is selected yes, evil, eyebrow, what is the probability they are yes, taco tongue? So whenever we see the word given, this is going to be whatever the bottom is. So out of the total evil eyebrow, so how many yes, evil eyebrow do we had? So out of the 18, what is the probability they are yes, taco tongue? So how many of them were yes, taco tongue? Okay. Done. That's it. Okay, given goes on the bottom. Good. Okay, there is a conditional probability question. You gotta draw a Venn diagram. So how would you draw a Venn diagram for this guy? Could you? Still?
His assignment, recommended assignment, there was one that's the Venn diagram. No, it wasn't a vote. The Venn diagram had three circles.
Mm-hmm.
And then the other, maybe that's you could just put the other.
The other.
Like the ones that don't spot.
That don't, you put it outside of the Venn diagram. Yeah. No, don't put a third circle. But looking at this one, if I were to draw a Venn diagram on this, I would have two circles. Okay, so where do they both cross over? What do they both say yes? 15. Okay, and then this guy's going to be evil eyebrow, and this one's going to be taco tongue, right? Okay, so who evil eyebrows but does not taco tongue? 3. Who taco tongue but does not evil eyebrow? Yep. And then who doesn't do both? Okay, it's outside of that. Make sure that you put kind of like a box around the Venn diagram so you say, hey, this is the sample space. Yep, yes.
I saw this one like the online.
Yeah.
And it had like a few diagram, but what percentage please in the start.
With percentages instead, you got to know the total group, and then you can turn it into the numbers. So like if I say 22% of 100, it'd be 22 people, right?
Yeah.
Cool. Okay. Going back to Nova's question about independent events. This was our formula for independent. Right? All three of those had to be true. Yes. Okay, now what about mutually exclusive? Okay, did we have anything on that? The line is given, yes. Did we have anything on mutually? How did we prove that two things were mutually exclusive? They can't happen at the same time, but then that means that probability of A and B would have to be 0. Cannot happen at the same time. The likelihood of them happening is 0. Good. These numbers cannot change, right? They all have to be the same. Mutually exclusive is this, where there's 0. Okay. Questions? Yes, Nova. Which one is it? On 5.1 or?
It's the.
Okay. Give me 1 second to get there. So this is talking about Chevys and 4-wheel drives. Okay, so the owner has a Chevy and the owner's truck has 4-wheel drives. Are they mutually exclusive events or are they not mutually exclusive? Are there Chevy trucks that have 4-wheel drives? Okay, so they're not mutually exclusive. Okay, so we got that part, right? So that can narrow us down to either this one. That's the only one that says are not mutually exclusive. So there's that. But what about independent? What did we say our formula was? Okay. All right, so what was the probability of A? What's the probability of owner has a Chevy? Okay, first, what do we got to do? Okay, so go ahead and add those. What's 28 plus 17? And what's 32 plus 18? And what's 20 plus 10? Okay, and then how much is that in total? Okay, so, and then you can add these up. Add up my no column. 45. Yes.
45.
Yep. Okay, what about this one? 80? Okay. All right. So what is the probability that an owner has a Chevy? 50 out of, okay. Is that equal to the probability of A given not B? So what would be not B? So yes, they have a Chevy, but no four-wheel drive. Okay, so out of the no four-wheel drive, how many have a Chevy? 18 out of 45. Are those the same? Say again. Why is it 45? So looking at this, we said A given B not. What was B? B was that they have a four-wheel drive, right? So we want not B. So they don't have four-wheel drive. Okay, so 18 out of 45 is what? 0.4. And 50 out of 125 is 0.4. Okay, what about this last part? A given B. Okay, so out of the four-wheel drive, yes. So out of 80, how many have a Chevy? Okay, 32 divided by 80 is 0.4. So those are independent. Okay, so what I'm going to do for you is I'm going to put that formula on the board. Okay, this is the one time that you get it. I'm going to put it on the board so that you have it so that when you're proving independence and mutually exclusive, you got those. Cool? I'll give you it now, but I'm not giving it to you on test. Then they're independent. Yeah? Yes, no, maybe. Okay. Basically, it's kind of like just because you have a Chevy, does it guarantee that you're a four-wheel drive? Not necessarily. Just because you have a Ford, does it guarantee you have a four-wheel drive? No. Okay. And we just proved that. Right? Yep.
What did you do with the B?
We're not do with the B.
We just got the total range, you divide it by, like, the total of Chevy, you divide it by the total, like, non-structural.
Okay, so we did the probability of A. That's how many Chevys out of the total number of trucks. Yeah, that was that first one. That's this probability. Okay, so on this next one, we did out of the people who don't have four-wheel drive, how many were Chevys? That make sense? Okay, and then this one is out of the people who do have four-wheel drive, how many were Chevys? We okay? So if it says the probability of A, that's out of the total. If it says given B, whatever B is, that's the bottom number. Yeah. You've got to make sure that you state what A and B are. If it's B not, it would be not four-wheel drive. Yeah. Still looking confused. You okay?